Yate mathletes. That means hello in Navajo. That's where I grew up. Anyway, we're going to talk about multiplying and dividing in rational expressions today and adding and subtracting. And we'll talk about what is a rational expression. Okay, so we're basically going to be just doing operations with rational expressions. So, a rational expression, just like we talked about rational exponents, are exponents that are fractions or ratios, right? Same thing with a rational expression. A rational, or the word rational in math, it doesn't mean like calm, cool, sensible, logical. It means a ratio, right? It means a fraction. So in math, when we say rational, talking about fractions, or ratios. So a rational expression is a ratio of two polynomial expressions. Okay, so it's basically just a fraction with polynomials, and it also could be monomials too. So, all right, and then a complex fraction is a rational expression whose numerator and denominator is also a rational expression. So in other words, a complex fraction is a fraction with fractions in it. Okay, so it's a fraction with fractions in it. All right, and a real quick example of a rational expression would be right here, right? We have fraction. We have a fraction where we have fractions within it, right? Fractions within the numerator and denominator. All right, now in terms of operating with rational expressions, it's the same as operating with fractions, right? It's just kind of we have to go from having constants to having variable expressions. All right, but it's the same idea. If we're trying to simplify and reduce, what we do is we divide by a common factor in the numerator and denominator, right? So the first thing is finding that common factor. Like you might be able to look at this and say the common factor, the greatest common factor is 6. You can divide by 6, right? But if you didn't know that, you would have to factor the numerator, right? And you'd say, okay, well, there's 2 2's and a 3. Then you'd factor the denominator, 3 times 10 and 2 times 5. And then you'd be able to identify, oh yeah, they have a 3 in common, right? And then they have a 2 in common. And so what you can do is you can cancel out those common factors, the 2's and the 3's, and then all you have left is 2 over 5. Okay? All right, so essentially we just divided by 6 on top and bottom, but this is a good way to do it, is to identify the factors first, then you can cancel, right? Okay, so now multiplying. Now with multiplying, we can reduce before and or after. Okay, so if you see something where anything on top reduces with anything on the bottom, you can do that. So you can cross cancel or vertically cancel when you're multiplying. Okay, so like here, for example, 6 over 10, I can reduce that to 3 over 5 by dividing by 2, right? And then I can see that over here, 15 and 3 have a common factor. So I can divide 3 by 3 and I get 1, and divide 15 by 3 and I get 5, right? So notice how I cannot reduce across, right? Just vertically or diagonally across, right? Okay, so now what I'm going to do when I multiply fractions or rational expressions, we just multiply straight across, right? Numerator times numerator and denominator times denominator. Okay, so numerator times numerator, denominator times denominator. So here I have 1 times 4 is 4, 5 times 5 is 25. And then if I can, I want to try to reduce after. In this case, I can't. And so we're done there. Okay. So if we wanted to, we could have reduced after. So I could have just multiplied first. 6 times 4 is 24. 10 times 15 is 150. And then I could have reduced from there and realized, oh, well, the common factor is, whatever it is. In this case, it would be 6. So then I would divide both top and the bottom by 6. And I would get 4 over 25. So you can do it either way. Okay. In general, I would say it's probably a little more efficient to reduce before because the numbers are smaller, so you can more easily see what the factors are. So, and then always check to reduce at the end to make sure your answer is fully simplified. All right, now dividing, this is pretty much the same thing, except we just have to flip that guy and multiply, right? We multiply the first fraction by the reciprocal of the second fraction. So I'm going to flip this around. Okay, I'm going to rewrite it as 5 over 8 multiplied by 4 over 3, right? And then now we can just, now it's back to what we did here with multiplication, right? So see if we can reduce 4 and 8, reduce it to 1 over 2. And so then we just multiply top times top, 5 times 1 is 5, and the bottom 2 times 3 is 6. So that's our final answer. So that's how we multiply and divide. So now with adding and subtracting, first of all, we have to calculate a common denominator, right? So adding and subtracting is a little different because we need the denominators to be the same in order to do it. That wasn't the case with multiplying and dividing, right? We didn't necessarily need common denominators with multiplying and dividing, but with adding and subtracting, we do. So what I want to do is find out what the least common denominator with these two values is, right? And one way to do that is to list out all the multiples and see which one matches up. That's the smallest. Another way to do that is by factoring, to say, okay, well, 18 is 2 times 9, which is 3 times 3, right? Okay, and 24 is 4 times 6, which is 2 times 2 and 2 times 3. So what we want to do is we want our common denominator to have everything represented here as well as everything represented here, but we don't want any duplicates, okay? Like we don't want to just stick all those together because then we'll get repeats. We'll get something that's more than what we need, right? It's wasteful. And so, so our LCD is going to incorporate everything that we had in the 18, the 2, the 3, and the 3. But once I get those, I can realize, hey, I already have a 2 and I already have a 3, right? And so really all I need is 2 more 2s. All right. And so what I'll do is I'll just multiply by 2 more 2s. Okay. So the LCD is going to be this product here. And so 2 times 3 times 3 times 2 times 2 is going to be 72. So that's our least common denominator. All right. So now what we do is we think about, okay, what do we need to multiply by this and this to get to that LCD, right? So for 18, I'd have to multiply by 4. So I'm going to multiply by 4 on top and bottom. For 24, we'd have to multiply by 3. Okay, so then what we'll end up with is 44 over 72 plus 51 over 72. Then we just combine those together. So remember, what we do is we keep the denominator the same and we just combine the numerators, right? So denominators stay the same when we add and subtract, and then we just combine the numerators either by adding or subtracting depending on the signs, right? So 44 plus 51 is 95, and then you just check to see can you reduce anymore, right? And in this case we cannot. So there are no common factors between 95 and 72, at least not bigger than 1, right? Okay, so that's how we add and subtract. Find common denominators and then apply the common denominators and then combine the numerators, and then if you can at the end, see if you can reduce. All right, now let's check out complex fractions. So complex fractions, once again, is where we have fractions within fractions. So what we want to do with these is we want to simplify the numerator first, just like as if it was its own problem. Simplify the denominator as well, independently at the same time. And then once you get down to 1 fraction over 1 fraction, then we're just going to divide, just like we did here. Okay, on that step, or on that explanation. All right, so first of all, here I have a whole number, right, or an integer, -9. So if you have an integer and you want to make it into a fraction, what do? Put a 1 underneath. That's right. And so now what I want to do is get the common denominator, which will be 2 in this case. So I'm going to multiply the top and the bottom by 2. So times 2 times 2. And then this one I can keep the same because it's already 1/2, right? So then what's going to happen is I'm going to get 1/2 minus 18 over 2, 18 halves. Okay. Then on the bottom, I want to do the same thing. I want to find a common denominator between these two. Now here, 6 and 7, 6 is 2 times 3, and 7 is prime, right? So I need 2, 3, and 7. So I need that whole combination. So 2 times 3 times 7 is 42. So I'm going to need 42. So I would multiply this by 7 on top and bottom, right? And then I would multiply this by 6. So this would turn into 7 over 42 plus, and then this would turn into 24 over 42. And what we'd end up with is negative 17 over 2, and on the bottom 31 over 42. All right. So we simplify the numerator, simplify the denominator. Now we're going to divide. Okay. So now we're going to divide the numerator fraction by the denominator fraction. And really it just turns into the same thing as dividing before, right? I'm going to flip that guy and multiply. So I'm going to take this numerator, negative 17 over 2, and multiply by the reciprocal of the denominator, right? So I'm going to flip that guy. 42 over 31. Then we're going to reduce. So here 42 and 7 have a common factor. 42 and 2. So it's 21 over 1. And so now we can just multiply top times top, bottom times bottom. So here we have a negative times a positive, so that'll be a negative. 17 times 21 is 357. And then 1 times 31 is 31. And no common factors there, so we can't, no common factors bigger than 1. So we can't simplify that anymore. Okay, so that's how we simplify complex fractions. Simplify the numerator and denominator independently. And then you can, once you get a rational expression on top, rational expression on the bottom, you can multiply the numerator fraction by the reciprocal of the denominator fraction. So hopefully that was a good review for you. Hopefully all that stuff was familiar. Maybe this was a little new with complex fractions. But the skills I think you all have from before, and maybe just need a reminder or two, or maybe not. But if you're good at these now, then that'll make life a lot easier for when we multiply and divide and add and subtract rational expressions. It's basically the same things, but with polynomials and monomials.